morning, students. I welcome you all for the other lecture on the course Computer Architecture and Organization. In today's class, I am going to discuss about the concept buses. First of all, what is meant by a bus? We know that bus is nothing but bunch of wires or bunch of lines which are helpful to us to provide a communication between different parts. So, in this class, I am going to discuss about the buses. In that, we are going to discuss about a very important one, that is two different types of buses. Those we can also call as two bus protocols. One is a synchronous bus and second one is a synchronous bus. I am going to explain these things in this concept. So, I am going to entering into the concept buses. Processor, memory and I/O devices are interconnected by means of a bus. We know that our system consists of major parts. One is a CPU, second one is a memory, and third one is an I/O devices. To provide a communication between all those things, we have a bus. Then the bus, what we can call is a system bus. That's why here we mentioned that processor, main memory and I/O devices are interconnected by means of a bus. What this bus can do? The bus provides a communication path for the transfer of data. What this bus can do? The bus transfers the data between the devices which are connected to it. For example, you consider your system. The system consists CPU, memory and I/O devices. Actually, this is I/O module, you know that. And communication between these three blocks, we are using a bus which is called a system bus, we know that. So, these three devices are connected to the system bus like this. What the use of this particular bus? This bus provides a communication between the CPU to I/O, or from I/O to CPU, or from CPU to memory, or from a memory to CPU, for the purpose of data transfer. So here that's what I am saying is, the bus provides a communication path for the transfer of the data. Fine. A bus protocol. What a bus protocol is? So it is very important thing, guys. Listen carefully. A bus protocol is a set of rules that govern the behavior of various devices connected to the bus as to when to place the information on the bus, when to accept the control signals, etc. So for this particular bus, these are the different devices are connected to it. What this bus protocol is? It is nothing but set of rules. What is the use of those set of rules? Based on those set of rules, these devices, when they are going to place their information on this particular bus, and what incident they are going to generate the control signals, or what incident they are activate the control signals. So these are the set of rules which are helpful to us to transfer the information between these devices. So that set of rules, what we are calling as bus protocol. I hope you understand what a protocol is. It is set of rules that govern the behavior of various devices connected to the bus, when to place information on the bus and when to assert the control signals, etc. Alright. So what the bus lines are? The bus lines may be grouped into three different types. We are basically talking about the system bus, you remember that. Because in the system bus only, we have these three different varieties of buses. One is a data bus, this is the first one. And second one is an address bus. And third one is nothing but control bus. These are three varieties of lines or buses exist in the system bus itself. So, the combination of these buses, what we can call is a system bus. We know what a system bus can do. The system bus provides communication between the major parts of a computer system like CPU, memory and I/O devices. So here the bus lines we divide into three different groups. Those are data bus, address bus and then control bus. What is the job of this data bus, address bus and then control bus? If you are thinking that direction, the data bus, it is nothing but group of lines or group of bytes which carries the data information. It not only carries the data information, it can also carry the instruction codes. So, this is a data bus which are nothing but a group of lines or group of lines which carries data information as well as instruction codes. These are two different varieties of information was carried by the first variety of lines or first variety of group of lines which we call as a data bus. Once again I repeat, the job of this data bus is the group of lines or group of bytes which carries the data information as well as which carries the instruction codes. So that is the job of this. And second one is the address bus. Again, these are the group of lines or a group of bytes which carries the addresses of either memory locations or the addresses of an I/O devices. I repeat once again, the job of this address bus is the address bus is nothing but a group of lines or group of bytes which carries the addresses of either memory locations or an I/O devices. So it carries addresses of either memory locations or an I/O devices. Coming to the third one, the control bus. This control bus is again a group of lines or group of bytes which carries the control signals as well as the request signals as well as acknowledgement signals. You remember friends, this control bus not only carries the control signals, it also carries the request signals, it also carries acknowledgement signals as well as this group of lines also carries the timing signals. That was important. So what this control bus carries? The control bus carries the control signals as well as request signals as well as acknowledgement signals as well as timing signals. These are the different varieties of signals are carried by this control bus. And then the combination of these three different buses we finally call as system bus. So this system bus provides a communication between your CPU, memory and I/O devices in your system. Right. The control signal specifies whether a read or a write operation we are going to perform in our system with respect to either memory or with respect to an I/O device. So what these control signals are? Our CPU going to perform either read operation or a write operation on a selected memory location or a selected I/O device. At a time our CPU can't perform both the read and writes. In our system, it can perform either read or write. Which operation our CPU going to perform on a selected device or a selected memory location, that was indicated by the control signals. So that's why here I written as whether it is a read or a write operation. One more thing is the required size of our data when several operand sizes are possible. Sometimes your CPU can do operation on bytes, sometimes your CPU can do operation on words, and sometimes your CPU do operation on double words. Again, what this control signals can specify is they specify what is your data size was. For doing a specific operation, the data size may be byte, or it may be word, or it may be long word, or it may be double word, or it may be quad word, like this. So this is also indicated with the help of the control signals. So the control signal specifies the first information, that is our operation is either read or it may be writes. The second thing is what your data size is. The The data what was involved in the operation is either in terms of bytes or in terms of words or in terms of long words. And as well as it also specifies the timing information to indicate when the processor and I/O devices may place data or receive data from the bus. At what time instant the data can be placed over the bus? At what time instant we receive the information from the bus? That the timing information also provided by the control signals or control bus. So here there are three different types of informations that can be carried by your control bus. The first variety of information that can be provided by the control signals was number one is operation is either read or it may be writes. And second one is what your data size was. The data size is either bytes or it may be word or it may be a long word. And third one is it also provides a timing information to indicate when the processor and I/O devices may place a data or receive a data from the bus. And next, there are different schemes for timing of data transfers over the bus can be classified into. That means here we are talking about bus protocols. We know that the bus protocol is nothing but it is a set of rules which are assigned to the devices which are connected to the bus. At what instant a device can go and place a data on the bus, as well as what time instant the device can activate or assert the control signals. So here there are two types of buses we are using in our system. This is we can also call as two types of bus protocols we are using in the system. One is a synchronous bus and second one is a synchronous bus. Or I can also call as a synchronous bus protocol or a synchronous bus protocol. These are the two different bus protocols we use in our systems. One is a synchronous bus protocol and second one is a synchronous bus protocol. Now I am going to discuss these buses one after another. So first I start with the synchronous bus. So in the synchronous bus, the steps of data transfer take place at a fixed clock cycles. What here we are seeing? In synchronous buses, the steps of data transfer take place fixed clock cycle. That means in fixed clock cycles only the data was transferred between two ends. In this synchronous data transfer scheme or a synchronous data transfer protocol or synchronous bus. I repeat once again, in this particular synchronous buses, the steps of data transfer takes place at a fixed clock cycles. In a fixed clock cycles only, the data was transferred between the two devices which are connected to the bus. That is the first point. Everything is synchronized to bus clock. That means what are the operations we are going to perform by using a bus? Those operations must be synchronized with a bus clock. This is very, very important. That means what are the operations we are going to perform on a bus? One thing is either sending of an address, or sending of a data, or sending of a control signals, we are sending a request signals, we are sending acknowledgement signals. All these signals must be synchronized with the bus clock. That is the second thing you have to remember regarding to the synchronous bus. And coming to the third, the clock signals are made available to both the master as well as the slave. Here what are this master and what the slave is? Here what we are seeing as the third point is the clock pulses, which is nothing but the clock signals, which is act as a synchronizing signal that was made available for both the master as well as the slave. What this is? For example, you can assume friends, this is some particular bus. This is some bus, which is nothing but a group of lines. And here I was connecting device 1 and this is device N. In between I have so many devices. These devices are connected to this particular bus like this. For example, device 1 want to communicating with the device N with the help of this particular bus. I repeat my example was device 1 want to communicating with device N with the help of this particular bus. In that incident, the communication was initiated by this device 1. Here the communication was initiated by device 1. So this device 1 we treated as a master, and the device N, which is targeted by this particular device. That means this device 1 targets device N for the purpose of either it may transfer something to device N or it may receive something from device N. In that case, this device N is treated as a slave who initiate a data transfer, that is act as a master who receives a data or who respond for communication of initiator or a master. That device we consider as a slave. So your clock pulse or clock signal is made available for this as well as this. That can be happened in case of synchronous bus. That was the third point. And coming to the fourth, the bus clock is a square wave signal. Generally, your clock signal is a square wave. I think everyone knows that what a square wave is. So who didn't know about a square wave, just understand this, guys. This is your square wave. The important property of a square wave was this is a T on period, and this we consider as a T off period. For a square wave, T on always is equal to a T off. On period is equal to off period. And the combination of on period and off period we consider as this is one complete clock cycle T. So here what I am saying as a fourth point is generally the bus clock is a square wave. That is a square wave. And coming to the fifth, a transfer may be multiple bus cycles depending on the speed parameters of a bus and two ends of a transfer. The data transfer may take multiple bus cycles. Here the important thing is, if you want to transfer something from device 1 to device N, the transfer not take a single cycle, it takes multiple cycles. That is purely depends on what is the speed of this bus transfer, what is the speed of speed parameters, what is the speed, at what speed we are transferring data from device 1 to device N. And also, it is also depends on two ends of the transfer. That means the distance between these two devices. If the distance between two devices is very far, no doubt that the data transfer takes much more time. It means that data transfer takes multiple cycles. If the distance between the two ends, that means the distance between a master and a slave, or the distance between an initiator and a destination, it is very less. It takes a less number of clock cycles for data transferring. So that's why here what we are saying is the transfer may take multiple bus cycles. That means if you want to transfer the information from device 1 to device N, it takes multiple clock cycles. It depends on two different parameters. One is the speed of data transfer, at what speed we are transferring data from one end to other end with the help of a bus, as well as it depends on the distance between the two devices. So that is a very, very important thing regarding to synchronous. So coming to this is an example for synchronous bus transfer. Here I consider only one particular clock. So from this to this, I consider as it is complete clock cycle. This is one complete clock cycle. In this we consider as T on period, and this is a T off period. I just told you that my clock pulse or a bus cycle or clock signal is a square wave. That means our T on period is exactly is equal to T off period. And this clock signal is available for both the master as well as the slave. So see here guys, so at this incident, I am going to send two different types of informations over this bus. That's why it can be representing with multiple bus. This is a representation of multiple signals. Previous case, this is only bus clock. That's why here I represent only one signal, that is single representation of a bus, and here it is multiple signals we are representing like this. Because here I was sending both address information as well as command information. And again here also I am representing a multiple bus structure, because here I am going to transfer a data. Data is not a single bit, it is a multiple bits. In this entire communication, I am going to divide this into T0 period, T1 and T2. So from T0 to T2, I consider as a bus cycle here that I can call as a clock cycle. That is a complete cycle which I am assuming as a T. How I can do an operation that is a write operation? If I want to do a write operation, what I have to do? And if I want to do a read operation, what I have to do with the help of this synchronous bus? With the help of some example, I am going to explain this particular structure. Right. In case of write operation, if my operation was write, that means master was to send something to a device which is connected to the same bus. It means your master want to send something to a slave. That operation we consider as a write operation. The master places the data on the bus along with address and the commands at the time instant T0. Whenever a master want to send something to a slave, first of all, what a master can do is it has to generate the address of a slave first. It has to generate address of a slave. So that's why it has to place address information over the bus. Once you send an address, at the same time, I would like to generate a control signal. With the help of that control signal, I indicate to the slave that I am going to do so and so operation on you. Here my operation is right. No doubt my master is able to generate a right control signal for this. That here what I can call as the command. And at the same time, I am going to transfer my data to the slave. For that purpose, I place the data, address as well as commands over the bus at a time instant T0. At time instant T0, I place these are three different informations on the bus. Because in my system bus, I have three varieties of lines: address lines, data lines, and the control lines. These are the separate. So at that time, I can go and use these three varieties of signals to transfer these three different varieties of information. One is a data, and second one is an address, and third one is a command, which is nothing but a control signal. These three informations are placed by the master on the bus at time instant T0. Fine. The slave stores the data into its input buffer at a time T2. See here, guys. At a time instant T1, T0, what my master can do is, it will go on to place both the data, address, as well as the command signals on this particular bus. That means at this time incident, my master places these three informations over the bus. And what happens at T2? In T2 time incident, your slave device grabs the information what already exists over the data bus into its input buffer register. So what are the slave which is connected to your bus, it have as an input buffer register. Your slave, what it do is at time instant T2, it grabs out of the information that is exists on the bus, or it takes out of the data that is present on the data bus into its input buffer register. That's what I am saying here. The slave stores data into its input buffer register at T2. Once the master places the device address and the commands on the bus, it takes time for this information to propagate to the devices. It's very important, yes. Because if you refer just now, I'll tell you one important point, that is the data transfer takes multiple cycles. Why? Because there I clearly mentioned that the data transfer depends on the speed as well as the distance between the devices. Once your CPU send an address, or once your CPU generate an address, the generated address is transferred to the devices with the help of a bus, that is an address bus. That address can be received by all the devices. It takes time, as well as once the address are received by all the devices which are connected to that bus, it has to go and decode that address. That address belongs to me or not. For that purpose, again it takes certain amount of time. Here it plays a vital role. So once a master places device address and command on the bus, it takes a time for this information to propagate to the devices. This time depends on physical and electrical characteristics of the bus. So here important thing is how much time it takes. How much time it takes. That means once your CPU generated an address that can be received by all the devices, and those devices can receive the command signals from the CPU end. How much time it takes for responding those devices for the commands which are issued by the processor. It is purely depends on the physical as well as the electrical characteristics of the bus. These are two characteristics, that is the electrical characteristics and the physical characteristics plays a vital role. Right. It also, all the devices have to be given enough time to decode the address and control signals so that the addressor slave can place data on the bus. This is the second case. For example, in this occasion, from this onwards, my focusing on how I can go and do a read operation. In a write operation, it is very clear for me. In time instant T0 itself, I can place an address information on address lines, command signals on a control signals, and data information on a data lines. I will transfer that information to all the devices. But those devices accept that information or not, that is purely depends on how much speed we are using for transferring of a data as well as the distance between the devices. With the help of that, we know that how we are going to do a write operation. But here important thing is how we are going to perform a read operation. That means a master wants something from a slave. Your master wants something from a slave. In that particular case, what your master can do is the master generate the address of a slave as well as the control signal, which is a read control signal. These are two signals once your CPU generates or your master cell generates. Those signals are received by the slaves. It takes time because these signals are carried over the bus and the distance between the devices are not synced. And all devices receive the address as well as the control signal. It takes time. That is the propagation delay plays a vital role. That is number one. And number two, what we are doing, what we are saying is, once a master sends an address, that address can be received by all the slaves or all the devices. Then what those devices can do is, they are going to decode that address. Once they decode that address, they can identify that this address belongs to me or not. For that purpose, it takes time. So here that's what I'm saying is that the time is purely depends on the physical as well as electrical characteristics. That's what I'm saying. And here all the devices have to be given to enough time to decode the address and control signals, and so that the addresser slave can place data on the bus. Once a corresponding slave identifies that the master generated address belongs to me, and it can understand that whatever the command signal or control signal already issued by the master to the corresponding slave, once it identifies the meaning of that, what it do is it will go and place its data on the data bus itself. Right? The width of the pulse depends on, that means your clock pulse width, which is your master signal, which is your synchronizing signal, which is your bus signal. That width depends on different parameters here. In that, the first parameter is maximum propagation delay between two devices connected to the bus. The bus width purely depends on. It depends on one of the parameters is the maximum propagation delay. For example, here I have one device and somewhere else here I have another device. These two devices are connected to this particular bus. The pulse width or bus width, don't think this is the width. I'm not talking about this. I'm talking about this width. This width. So that means these are devices who are transferring their information from one device to another device. They took the reference. This is that bus clock. This bus clock width depends on one of the parameters, maximum propagation delay. What is the delay that can be taken care by this device, this bus, to transfer the information from this end to this end? So the propagation delay between the devices connected to the bus, this is one thing. And second thing is the time taken by all devices to decode the address and control signals so that the address slave can respond at time t1. So once the first thing is once the devices receives the address as well as control signals, that is purely depends on the propagation delay. And number 2 is the decoding time. Once the devices receive the address and the control signals, they take certain amount of time to decode the received address as well as control signals. According to those control signals, the corresponding slave can respond to the master signals. So I hope you understand something about a synchronous bus. The continuation of this synchronous bus, I'll go and discuss in next class. Thank you for patiently listening.